In a mere 23 years, SpaceX has skyrocketed from begging for NASA's scraps to potentially dwarfing NASA's entire yearly budget. A growth so obscene, it'll make your head spin. How did they pull off this insanity? It's all down to one ruthless strategy: diversify or die. SpaceX didn't just play it safe. They threw their bets across government deals, commercial launches, Starlink's satellite internet domination, and beyond. That wasn't just smart, it forged a galactic empire. Now Sierra Space is stealing that playbook and cranking it to 11, diving headfirst into defense to challenge the Titans. This unicorn isn't here to play nice. It's gunning to outmuscle SpaceX itself. With Dream Chaser, their sleek runway landing spaceplane that's equal parts sci-fi and game-changer, Sierra's stacking contracts and turning heads. Its versatile missions and bold moves have the aerospace world shook. So how's Sierra Space plotting to take on the industry's heaviest hitters? I'm David, joined by the Starship Mission Update team, and we're tearing into it today. How harsh is rocketry? Rocketry is far from a walk in the park, especially for private companies looking to turn a profit by launching rockets. The hurdles are massive and come down to two major factors: technical challenges and financial pressure. Let's start with the tech side. Building rockets is insanely complex. Everything has to work perfectly. Just one small error can cause the whole thing to blow up. And when a rocket explodes, it's not just a spectacular failure, it's also a multi-million-dollar loss that sends shivers down investors' spines. On top of that, launching rockets requires specialized infrastructure, which costs a fortune. Then there's the environment these machines operate in. Rocket engines reach extreme temperatures and must survive the harsh conditions of space. Finding materials that can withstand this is no easy task. Many of these components are rare or hard to source, leading to delays or skyrocketing costs. Now imagine trying to push boundaries in this already punishing field. That's what visionaries are doing, challenging the status quo. NASA, for example, struggled with its partially reusable space shuttle and eventually returned to disposable rockets. Meanwhile, companies like SpaceX are doubling down on reusable systems to cut costs. But making a rocket safe and reliable for multiple flights, that's a massive engineering puzzle. On top of all that, the legal and regulatory side of things is a maze. If you're partnering with NASA or other governments, there's a rulebook you have to follow. And space debris? Yeah, companies are now being held accountable for cleaning up after themselves. Think of it like an environmental tax for space. So how do you stay afloat in this brutal industry? You need serious financial muscle. Most rocket startups are either backed by billionaires or rely on deep-pocketed investors and partners. And raising that money is just the beginning. Staying in the game long-term requires a sharp business strategy, and that's where diversification comes in. Rather than betting everything on rocket launches, private space firms are branching out. They're moving into satellite communications, space tourism, in-orbit servicing, building space stations, exploring the moon, you name it. This diversification often means developing cutting-edge tech like reusable rockets, space planes, or even in-orbit manufacturing facilities. Business models are evolving too, with ideas like point-to-point space travel and commercial space stations becoming serious plays. On the business side, many of these companies also pursue both government and commercial contracts. This mix brings in stable government money while keeping innovation moving fast through commercial work. And if we're talking about pioneers, look no further than SpaceX. Their Starlink satellite network has become a financial powerhouse, helping fund the incredibly ambitious Starship program. And that's just the civil side. On the defense end, they've rolled out Starshield, a secure comms network designed for military and intelligence use. Starshield is one of many Department of Defense contracts they've landed. This strategy of straddling civil, commercial, and defense markets gives SpaceX a diversified revenue stream and a unique edge in the space race. Plus, they've got plans for space tourism with their Crew Dragon spacecraft and even Earth-to-Earth travel via Starship. And the payoff is so sweet. Elon Musk, claims that SpaceX's commercial revenue will surpass NASA's entire budget by 2026. And while that sounds wild, another space player is making waves on a similar path. Meet Sierra Space, a company just 4 years old already known for its eye-catching Dream Chaser spaceplane. It's on track to resupply the ISS under NASA's Commercial Resupply Services 2 contract. But now they're stepping into defense, echoing SpaceX's transition from scrappy startup to aerospace powerhouse. On June 11th, Sierra Space unveiled its new Victory Works facility in Centennial, Colorado. This 60,000 square foot addition is supercharging production of their Eclipse satellite bus, a key piece for the U.S. Space Development Agency's missile warning systems. Backed by a $1.5 billion contract portfolio, this marks a serious shift. In fact, they recently landed a $740 million contract for 18 satellites loaded with next-gen fire control sensors. That's not just tech speak, it's a crucial upgrade to America's missile defense. This pivot to defense comes at a time when the 2024 U.S. Space Force report is emphasizing the urgent need for rapid satellite deployment in response to global threats. And Sierra Space isn't stopping there. Through NASA's Next Space Technologies for Exploration Partnerships, Next Step 2, Appendix R program, they're exploring how to use expandable space station tech like their Life Habitat for lunar logistics, including tunnel networks, cargo storage, and the infrastructure for a permanent moon base. All part of NASA's Grand Moon to Mars vision. And there's more. Dream Chaser isn't just a delivery vehicle. It's also conducting microgravity experiments like 3D printing protein crystals for pharma giant Merck. The goal? Unlocking new possibilities in cancer treatment by making drugs more precise and effective. If that's not future forward, what is? Dream Chaser, with some unique advantages, will be the key to unlocking a future that some say even SpaceX cannot deliver. Dream Chaser stands out for its airplane-style reusability. Most capsules, like SpaceX's, splash down at sea or land in a few spots. Dream Chaser? It lands like a regular jet on standard runways around the globe. No massive Mechazilla launch towers required. That means quicker turnarounds, lower infrastructure costs, and faster access to whatever it brings back, be it astronauts, sensitive cargo, or emergency supplies. Flexibility is the name of the game. Dream Chaser can haul crew, cargo, perform satellite servicing, do science in orbit, and even assist with Earth observation. It's basically the space version of a Swiss Army knife. Plus, it's rocket agnostic. It can fly atop multiple launch systems, making mission planning more versatile and resilient. And here's a big plus. Unlike some spacecraft that rely on hazardous fuels, Dream Chaser uses non-toxic propellants. That makes it airport-friendly and lowers operational costs. Oh, and remember SpaceX's vision for point-to-point travel on Earth? Sierra Space is chasing the same goal, ultra-fast global cargo delivery using spaceflight. Think military supplies or disaster aid delivered in just hours. Game changer. Dream Chaser can also remain docked at the ISS for up to 210 days, just like SpaceX's Dragon. And it's upgradable to survive harsh radiation, meaning it's ready for extended military ops. Safety? Covered. In a launch emergency, it can autonomously abort and land safely on a nearby runway. No ground control needed. Sure, it has limitations, mainly a smaller payload compared to Falcon, New Glenn, or Starship. But for missions that require precision timing or ultra-sensitive cargo, Dream Chaser might be the perfect fit. And let's be real, NASA and the Department of Defense wouldn't be investing big bucks if they didn't see the potential. So what do you think? Is Dream Chaser the next big thing in space tech? Drop your thoughts in the comments. I'd love to hear your take. Anyway, if you love this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 20,000 subscribers, and we need you to get there. Check out our other videos on Starship, Artemis, and more, and let's keep exploring the cosmos together. Any NET launch date yet? Dream Chaser is great, but is there a confirmed launch date yet? That question has been echoing through the space community for years. Enthusiasts and experts alike have been eagerly awaiting its debut, yet we're still waiting. Back in 2020, Steve Lindsay, SNC's Vice President of Space Exploration Systems, was confident that Dream Chaser would launch in 2021. Fast forward 4 years, and it's still Earthbound. The first cargo variant, fittingly named Tenacity, is currently undergoing final tests at NASA facilities. The new target? No earlier than the third quarter of 2025. So what's caused all the delays? Launch logistics. Dream Chaser was originally slated to fly aboard ULA's Vulcan Centaur rocket, but ULA had to prioritize getting Vulcan certified for vital U.S. Space Force missions. As a result, Dream Chaser was bumped in favor of dummy payloads. While there's a potential launch window for Tenacity in late 2025, nothing is locked in. ULA is currently juggling a dense queue of military launches, putting that 2025 timeline in jeopardy. They did consider a backup plan, the reliable Atlas V. But there's a catch. ULA stopped producing Atlas V in 2024, and only 14 launches remain to fulfill existing commitments, including Boeing's Starliner and other high-priority government missions. Dream Chaser getting one of those slots? Not likely. Another reason for this delay might be the technical hurdles. Dream Chaser uses landing gear for runway landings, similar to how NASA's Space Shuttle operated. The shuttle had 3 sets of landing gear that extended through doors in the heat shield. To save weight, these gears couldn't retract once deployed. And because extending them too early would compromise the heat shield, a potentially fatal flaw, they could only be deployed manually, with no backup automatic system. Landing the shuttle was a high-stakes operation. It approached the runway at high speed, and once committed to land, there was no turning back. The landing gear had to work perfectly on the first try. Failure was not an option. So what if the shuttle's landing gear failed to deploy? In short, disaster. The orbiter wasn't structurally designed to survive a belly landing. If the cargo bay were empty, there might have been a slim chance for the crew, but if it were carrying payloads, the cargo could slam forward into the crew compartment on impact, likely resulting in tragedy. Now, Sierra Space is hoping to overcome these same risks. Adapting a legacy design like the Space Shuttle for modern use in Dream Chaser is a massive engineering challenge. Just look at the development timeline for their first flight-ready prototype, Tenacity.